So for 8b.9, we're going to actually be solving log equations. So this time I'm going to be giving you log equations. So with the equal sign, we're going to solve for what's inside. Just quick reminder of the rules. You do not have to write these down because you've already written them down. Product rule. If I am multiplying inside of my log and I want to split them up, what do? You add them. If I am dividing inside of my log and I split them up, what do? Subtract. And if I have my log to a power, I can bring it down in front and multiply that times my log, okay? So here are your steps to evaluate or to solving logs or evaluating. First thing you are going to do is you are going to condense the log into a single log with the same base on each side, okay? So you're going to take your log and you're going to condense it so you have one log on each side, and it should be the same base on each side. Then you are going to be able to drop the common base. So just like 8a, we're trying to get the same base on each side, so the same log on each side, and then you can drop your bases, and then we set the insides equal to each other. So your last step is going to be to solve for x. So the most common mistake that I see when I give students these types of problems is a lot of times they skip the first step. So they see that they have logs and they just drop all the bases and set everything equal to each other. But you can't do that because you have to have one log on each side. So it's just like when we were solving exponential equations. So just like when we were solving exponentials, if I gave you 3 to the x equals 3, let's say, to the 2x times 3 to the 4th, could you just drop all of the bases at this point? No, what did you have to do first? You had to put these two together, right? And what did you do with the exponents? You added them. So this would be 3 to the x equals 3 to the 2x plus 4, and then you could drop your bases, right? Okay, that's one common mistake that I see, is that students don't condense. So if you don't condense on one side, your operation is the wrong one because you didn't put them together. The other mistake that I see is not getting one log on each side. So what if I gave you this? 3 to the x equals 20, let's just say 27. And then I get students that say, oh, okay, we can drop the base and x equals 27. Can you do that? No, because 3 to the 27 is definitely not equal to 27, right? Well, I know. The whole point is that we're doing the exact same thing that we did in Unit 8A, except that everything is written in log notation instead of exponent notation. But otherwise, this is the exact same thing. So you have to keep the exact same rules. So we have to condense so that there's just one base on each side, and there has to be the same base on each side before you can drop the bases. Does that make sense? Okay, so let's look at some problems. If, and this is just a notation, you don't have to write it down, but I believe it does show up on your homework. If you have E as part of your answer because you were doing a natural log or something, leave it as an E. So don't write as 2.71, okay? Leave it as an E and leave your answer in terms of E, okay? Sometimes there will be no solution, so just a heads up. So let's look at number 1. So number 1, we have log base 2 of 3x equals log base 2 of 96. So in this problem, the first thing I'm going to do is I'm going to look to make sure that I have only one log on each side. And in this problem, I have log base 2 on the left and log base 2 on the right. So I don't have any condensing that I need to do. So I'm going to drop those bases, and that leaves me with 3x equals 96. So it's exactly like when we do this in exponent notation. This is just in log notation. So we drop the bases and we set the exponents equal to each other, and then we solve. So divide both sides by 3, and x equals 32. And you should get answers that make sense when you plug them back in. So if I were to plug in x equals 32 back in, that would be log base 2 of 3 times 32, which is 96. So we would have log base 2 of 96 equals log base 2 of 96. So you should end up with the true statement if you were to plug your variable back in. Okay? All right, so number 2, we have 2 log base 5 of 4 equals log base 5 of 2x. Do I have just logs on each side? No, I have this 2 in front. So what do I have to do before I can drop my bases? Do the exponent. So this is going to be log base 5 of 4 squared equals log base 5 of 2x. And I do want you to write that step. And now that I have log base 5 and log base 5 on each side and only one of them, I can drop my bases. 4 squared gives me 16, so that's 16 equals 2x. Divide both sides by 2, so I get x equals 8. Okay, so number 3, we had log base 6 of 3x equals log base 6 of 81. First question, is there any condensing to be done? Okay, so the next thing we can do is we can drop the bases, and we would get 3 to the x equals 81. What did you guys do next? Okay, so 81 is 3 to the 4th, and then we can drop the bases again, and x equals 4. So in this case, we ended up doing the same process twice. So number 4, we have log base 2 of 3x plus 7 equals log base 2 of 4x minus 8. Is there any condensing? I don't see any because this is log base 2 of a quantity, and the other side is log base 2 of a quantity. So you can only condense if we have separate logs. This one is inside one single log, so it's one single term. So we can drop the log, and that's 3x plus 7 equals 4x minus 8. And what would you guys do next? Add the 8. Okay, so let's add 8. And then subtract 3x. Are you guys okay if I do that all in one step? Okay. So that's going to be 15 equals x. So if we were to plug in 15 for x into each of these logs, they should all, after we evaluate each one and simplify the parentheses, we should end up with 2 logs that are exactly the same. Okay? Okay, number 5. We have log base 4 of x minus 2 equals log base 4 of 25 minus log base 4 of 5. Can somebody please tell me what is the difference between the left-hand side and the right-hand side? Yeah, the left side has 1 log with x minus 2 in parentheses attached to it, and the right-hand side has 2 separate logs. Which side is going to be the one that we can condense? The right-hand side. So condense the right-hand side. If it's subtraction, what are you going to be doing? So this is log base 4 in parentheses x minus 2 equals log base 4, and I do want you to write it as 25 over 5, so that I know that you use the quotient rule. Okay? Okay, so now we can drop the bases, and that's going to be x minus 2 equals 25 divided by 5 gives me 5. And then when we add 2 to both sides, we get x equals 7. Okay. Okay, so I heard a lot of you say that we could condense it. So we have natural log of 2x plus 3 minus natural log of x minus 2 equals natural log of 4. So on the left-hand side, we can use the quotient rule, right? So that's going to be natural log of, in parentheses, 2x plus 3 divided by x minus 2. Did everybody get that? Equals natural log of 4. Okay, now I only have natural log on each side, so I can drop those bases of natural log, and I am left with 2x plus 3 over x minus 2 equals 4. Let me put this in terms of a simpler problem for you really quick, and then we'll see if you can figure out what to do next. Anytime you have been given a problem that looks like this, let's say x over 3 equals 10. What would you do to solve for x? Multiply by 3. Because then your denominator reduces, right? And we would get x equals 30. So what could we multiply by in this problem to get rid of that denominator? So multiply both sides by x minus 2. Because that's x minus 2 over 1, and so your x minus 2 is reduced. So that gives you 2x plus 3 equals, I'm going to distribute in the same step, 4x minus 8. Let me turn this over. Okay, what would you do next to solve? Subtract 2x. Okay, so subtract 2x and add 8. And I'm going to do both in the same step again. So add 8, subtract 2x. Okay, so we would end up with 11 equals 2x, and then to solve for x, you would divide by 2. So we end up with x equals 11 over 2, which is okay. Leave it as 11 over 2. Don't give me 5.5. Just leave it as 11 over 2. And that's an okay answer. Okay, number 7. Okay, number 7, I have log of 3 to the 2x equals log of 27. Guys, what would be your first step? Okay, so we need to make sure that they're in the same base. This one is a log and this one is a log. So is there any condensing to do? Do we have log on each side? So can we drop them? Yep. So that's going to be 3 to the 2x equals 27. And then what would you do? Yeah, so 27 is 3 to the third. So that's 3 to the 2x equals 3 to the third. Drop the 3's. And so we end up with 2x equals 3. Solve for x, so we divide by 2. So we end up with x equals 3 over 2. All right, last one. We have log base 7 of x equals 2/3 log base 7 of 27 minus log base 7 of 5. So let's start condensing. What do you guys see that we should do first? Yeah, let's do the exponent first. So that's going to be log base 7 of x equals log base 7 of 27 to the 2 over 3 minus log base 7 of 5. And then what else can we do? Condense again using quotient rule. So let's log base 7 of x equals log base 7, and I'm going to rewrite 27 as a radical. How would you rewrite 27 to the 2 over 3 as a radical? Cube root of 27 squared, and then we're going to divide all that by 5. And now can I drop the bases? Yes, so drop that log base 7. So this is x equals, okay, let's simplify a little bit. What's the cube root of 27? 3. So that's going to be 3 squared over 5. So x equals 9 over 5.
page?